So in part D of this question, we were asked to find the absolute minimum of f on this minus 2 to 8 interval. So firstly, let's consider where can there be a minimum. Well, where the derivative is equal to 0. So we need f prime of x to equal 0. So from this, we can see on the graph, x is equal to 0. I mean, f of x is equal to 0 at minus 1, at 2, at 6. However, it is also possible that the function, since it is continuous on this interval, it is also possible for the minimum to be at either of the endpoints. So in that case, the derivative there doesn't have to be 0. You can simply take the smallest value at one of the endpoints. So we need to add minus 2 and 8 as well, as those are the two endpoints. And so what we need to consider here is each of these points and where could the local minimum be. Well, at x equals minus 1, we can see it's not going to be correct because here before minus 1 the slope is positive, after minus 1 the slope is negative, which means it will be a local maximum, not a minimum. We can also eliminate minus 2 because it is positive, so the slope is going to be positive and therefore is going to be smaller than minus 1. And what we can also consider is that we've already said in part A that f at 6 there cannot be a max or a min. Therefore, this is also going to be incorrect. And well, from 6 to 8, the function is increasing. Therefore, again, that cannot have a local minimum or maximum, especially because the function value at 8 is going to be larger than the function value at 6 because, again, the slope is increasing over here. Therefore, this can also not be correct. And if we look at x equals 2, then we see that before the slope is negative, after the slope is positive. Therefore, we do have a local minimum. And since none of the other points are really possible, therefore, f of 2 is going to be the local minimum. And we're given in the question f of 2 is equal to 1.